Say, hey, I'm here today. Yeah, it is hard to read. He did it in orange. I think he thinks we can't read his handwriting and he wants me to rewrite it every day, and I'm not rewriting it every day. So it is hard to read. It says, when the sun has set and the light has disappeared, a new day will come. And today, our job is to do the task. I'm just going to show you how we do task 1 and task 2, so then you can do those today. So the first thing you need for this task is some sort of container. You know, a kettle, or a coffee pot, or a cup, or just a bucket. It doesn't matter what it is. Pick some sort of container. I'm going to use a kettle. All right. That's number 1. You just need a container. Grab a container. Number 2, you need items that you can make 2 groups in that are similar. Similar items that you can make 2 groups of. So for instance, pens and pencils. Or here I got some PlayStation 2 boxes and some PlayStation 4 games. Something similar to this 2 groups. I'm going to use M&Ms. That's my plan. Use M&Ms. But just pick any old items around your house. Look for something around your house that's similar to one another, and yet you can make into 2 groups. Next, I'm going to use M&Ms. So I'm going to open up my M&Ms. And what you want is 8 of one item and 2 of the other. So let me grab this back again. Pretend I was using the pens and pencils. I might do 8 of my pens. 1, 2, 3, 4, 5, 6, 7, 8. And 2 of the pencils. So that I have a total of 10 items. Or maybe 8 PlayStation 2 games and 2 PlayStation 4 games. Okay? So you need a total of 10 items, 8 of one and 2 of the other. So for my M&Ms, I might pick red to be one group and not red to be another. So I got red and not red as my 2 groups. So I would do 2 red M&Ms. Can you see the table? Maybe not. 2 red M&Ms and then 8 of the others. So 2, 4, 6, 8 of the others. Okay, the table's not quite high enough. Either that or my camera needs to go low enough. Oh darn. Okay, anyway, so you got 2 and 8. All right. So those are the things you need: a container, items that make 2 groups, and then you're going to do 8 of one and 2 of the other. I'm going to do a little bit different numbers, just so that I'm not doing exactly yours for you. I'm going to do a little bit different numbers. Instead, I'm going to use 3 of one, 3 of one, and 7 of the other. So 4, 5, 6, 7. Okay, so my numbers are a little bit different than yours, just because so I'm not doing exactly your homework for you or the task for you, but it's going to be really similar. All right, but you're going to have 2 and 8. Then you also, before you put it in, decide which is which. So the 2 is your black, and the rest of them are your white. So in my case, my red are my black, and the rest of them are my white. Or maybe I should do... maybe I should just go ahead and make it black so that we're not confused. 1, 2, 3, 4, 5, 6, 7. So I've got 7 here that these are going to be white, and these are going to be my blacks. And mine's a little bit different. You're going to have 2 and 8, but I've got 3 and 7. Okay, then what you do is you just put it inside your container. So I'm putting all of my 10 items in my container. And then we're going to find a way to select them randomly. So, maybe all you're doing is you're just reaching your hand in and picking one out. Or maybe you find a way to pour it out. So I'm going to do that. I'm going to pour mine out, because I have this kettle here where I can pour it out. I'm going to take it out and I'm going to look at it. And I'm going to choose 3 of them. So in task 1, you're supposed to choose 3 of them without replacement. So I'm going to do that exact same thing. I'm going to take 3 of them out. So 1, if you were doing it with replacement, you'd put it back in and then you take it out again and look. Okay, but without replacement, I'm just going to take out 3 of them. 1, 2, 3. And I'm going to look at them. And then I'm going to count the number of blacks that I've got. Okay, so let's start. I'm actually going to skip down to your 9th thing that you're supposed to do on the homework, because I want to, even before I begin, I want to kind of think about what's going to happen in this experiment. By the way, it says when the sun has set and the light has disappeared, a new day will come. So, the sun will come up tomorrow. Okay. All right, so there's your haiku for the day. All right, so let's just think about what we can do. If I'm taking 3 things out of there. So I've got this bucket of stuff. I'm going to pull out 3. I'm going to look at them. I'm going to put them back. And what I'm doing is I'm counting the number of blacks. So if I'm taking out 3, what's the minimum number of black marbles or M&Ms or items that I could get? What's the smallest number of black items that I could get? If I'm pulling out 3, choose 3 without replacement. Okay, so this is task 1. Task 2 is the same, only it's with replacement. But we're going to look at the one without replacement first. So here we go. What's the smallest number of blacks that I can pull out? If I'm going to pull out 3, look at them, and count how many blacks I have then. What's the smallest number of those black M&Ms that I could get? I could get 3. That is one thing I could get. I don't think that's the smallest, but I could get 3 of them. I'm going to put that on there. So this X here is the number, let me do a better job of this. The number of black that I could get. I agree with Ann Kara that I can get 3. How many else could I get? 0 is the smallest. Good. I can get 0. Good, Courtney. I could get 0. How many else could I get? Okay, so that 0 is the smallest and 3 is the biggest that I could get. What else could I get? However many else could I get? If I'm pulling out 3 and looking at them, how many black could I get? So I could get 0, or I could get 1, or I could get 2, or I could get 3. Okay, Mr. Simpson, I will. All right, so this is going to be our number of black, the number of blacks that we get. That's our random variable. And we call that X. Our random variable then is X. Perfect. Okay, so we can do 0, 1, or 2, 0, 1, 2, or... Okay, so now, without actually doing the experiment yet, I want to know what is the probability then that I get 0. What's the probability that I get 0? So again, what I'm doing is I'm going to choose 3 without replacement, and I'm going to look at them. So let me show you again. I'm going to take my container that has my 2 different things in it. I'm going to open it up. I'm going to take 3 out of there. 1, 2, 3 things out of there. I'm going to look at them, and I'm going to count the number of black balls. So from our classical probability the last 2 days, how could we get 0 balls? How could we go about getting 0 black balls? What would we have to get out in order to get 0 black balls? So first thing we want to do is use the words. That's the first task. Don't try to put numbers with it yet. Remember, when we're doing the probability, we want to first use our words. And we want to include those words like and or to help us with the probability. So in order to get 0 blacks, I would have to get a not black and a not black, or you could call it instead a white, because yours are we're dividing them up into 2 categories, white and black. So yeah, good, Courtney. But remember, Courtney, we want to use the word and in there. So instead of saying getting 3 white balls, what we want to do is say white and white and white. So white and white and white. Remember that when you are writing it out, you want to make sure that you're doing each, on the first draw, what would I have to get? And on the second one, what would I have to get? In other words, you're using those conjunctions of and or, just like you did on the first assignment, that day 1 classical probability. You made sure to use the words and or on your assignment. Okay, so now I'm going to do the classical probability for mine. Now remember, I have in my example, I have 3 blacks and 7 whites. But you're going to have 2 blacks and 8 whites. So yours will be a little bit different than mine, just a little bit. Your numbers will be just a tiny bit different. But basically, they're going to be the same other than that. Okay, so in order to find the probability of mine, now that I have it in words, in order to find the probability that I get 0, what I do is find the probability on my first draw. So what is the probability on my first draw that I'm going to get that I'm going to get out of a white? Well, there are 7 whites out of a total of 10 M&Ms in there. So my probability is 7 out of 10. Now, yours will be a little bit different, but mine's 7 out of 10. The and tells me to multiply. If I get a white out on the first one, because it's without replacement, I no longer have, so let's just do a little bit of it. Let's just show you what's going on here. So, I'm doing, taking one out, and sure enough, I got a white one in, I got a white one out. So now, what's the probability I get that second white one out? How many are left in there? How many whites are left in there? Now there are only 6 whites in there out of a total of 9 M&Ms. But in order to give me another white, the probability, so it was a 6 out of 9 chance, and I failed that time. But to get another white, it would be 5 out of 8. You're exactly right, Bo. 5 out of 8. Yeah, y'all have got it. Good. Okay, so what is the probability then that I get 0 blacks? Well, now we just multiply to find out. I'm going to simplify first. So notice that 5 goes into 10 2 times. 6 has a 3 in it. And 9 has a factor of 3, so I can simplify that to 2/3. Then also, here I'll go ahead and write that out. So what I have so far is 7 halves times 2/3 times 1/8. But do you see this 2 and that 2? Those guys can go away. So on top, I'm just left with 7, and on bottom is 24. So the probability that I don't get a black is 7 out of 24 times. If I do this experiment 24 times, if I do 24 trials of it, then I would expect 7 of them for me to get no blacks. That would be my expectation. It doesn't mean it'll happen, but that's the expectation. Okay, so we've done our 0. Now your numbers are going to be a little bit different because you're going to have 2 blacks and 8 whites, but you kind of get the idea. Then, before we find out in order to find out the probability I get 1, now we're going to find out the probability I get 1 black. And in order to find that out, first we want to put it in words. So how can I go about getting out 1 black? What would I have to draw to get out 1 black? I could get the black on the first one. If I get the black on the first one, then my other 2 draws, I'd have to get and a white and a white. I would have to get a black and a white and a white. Perfect. A white and a black and a white. Good, Amani. A white and a black and a white. Is there another way that I can get just 1 black? I like it. So we got a white and a white and a black. And that's all 3 ways that I can get it. Great job, guys. So now I just put the probability, now that I have the words with it, now I'm just putting the probability with it. So what is the probability I get my black on the first draw? Well, there are 3 blacks out of 10. And tells me to multiply. I'm without replacement, so I'm going down each time. So I'm going to do 9 and then 8. How many whites are in there? Well, I haven't taken a white out, so I have 7 whites still. But now I've taken a white out, so now I just have 6 whites left. Or, so that tells me to plus. So now that I've got those words down, now I'm just adding the probabilities to it. So a probability of a white on the first draw is 7 out of 10, because there are 10 marbles, or M&Ms. And, well, I haven't taken out a black, so it's 3 out of 9. And it's going to go down because it's without replacement. I did take out a white here, so over here I'm down to 6. Or that last little bit, white is 7 out of 10 and 6 out of 9 and 3 out of 8. Still goes down. Here's my whites, there's my black. Notice that on top, every time it's the same numbers. They're a different order, but it is the same numbers. And the denominator also. So really, once I find out one of them, I could just multiply it by 3. Let's do some simplification. So 3 goes into 9 3 times. Oh, but 3 goes into 6 2 times. And 2 goes into 8 4 times. So I'm left with 7 on top and 10 times 4 on bottom, or 7/40ths. But I know I'm going to end up with 3 of those. This is going to end up being 7/40ths, and this is going to end up being 7/40ths. So I have, add those 3 together, 7/40ths plus 7/40ths plus 7/40ths, or multiply by 3, whichever way you want to do it, and you got 21/40ths. So the probability is 21/40ths for just drawing one 40ths, for just drawing one out of there. Now, we want to draw 2 blacks. So tell me, how can I get 2 blacks? Good, Adam. How can I get 2 blacks? So I've done it with 0, I've done it with 1. Now I'm going to do it with 2. By the way, this is number 9 on your task, making the classical probability distribution. You're your numbers are going to be slightly different. Because I'm using 7 whites and 3 blacks, and you're using two blacks and 8 whites. All right, but you told me how I can get, how I can do 2 blacks. I can do what? Oh, good. A black, and a white. Or, perfect. White, black, and black. Or that last one is in the middle, right? So black and white and black. So I've got 3 different ways that I can get 2 blacks. Now I just put the probabilities with it. So again, I've got 3 blacks to begin with. My number on bottom is going to go down because I'm doing it without replacement. Same thing here. My number on bottom is going to go down because it's without replacement. Number here is going to go down because it's without replacement. On top, I have 3 blacks and then 2 blacks. So for every one of my blacks here, I'm going to have 3 blacks and then 2 blacks. 3 blacks and then 2 blacks. Once I've taken out 1 black, I only have 2 left. And then I have 7 whites on all of them. So the numbers are the same. And I love how y'all are commenting. You're saying exactly the right thing, that it's going to do it over and over and over again. So that really once you find out this 3, you just have to find out this probability once and multiply it times 3. So that's exactly, y'all got this. Great job. Okay, so I'm going to just find out the probability once. I'm just going to do this. We'll just do it right here on bottom. So that this is 1/4. The 3 goes into the 9 3 times. And all I'm left with is 7 on top and 10 times 3 times 4 on bottom. And I'm going to take that probability, whatever this probability is, it's 1, 2, 3 of them. So I'm going to multiply that whole thing by 3. Okay, so anyway, notice that this is 3 because it's 1, 2, 3 of them. And then the probability of this guy is sitting right there. So there's the 3 and there's this 3 and that 3. I'm going to cancel them out. So even before I multiplied, I went ahead and just canceled that out. So that I end up with 7 over 40. So there we go. 7 out of 40 is the probability that I get 2 blacks. Now I'm down to 3. And we're going to do, find the probability that I get 3 blacks. All right, so the only way I can do that is to get 3 blacks is I have to get a black and a black and a black. Now I'm going to do the probability of each one of those. So there's 10 to begin with, and 9 and 8. I start with 3 blacks, but now there's only 2 in there because I took 1 out, and then there's only 1 in there. And that's the only way to do it. Now, the difference between the with replacement and the without replacement and the with replacement, so in your task 2, you're doing it with replacement, so then your denominators just won't change. Your numerators will, and your numerators won't change because you'll keep being putting it back in. So on the with replacement, you're just not going to change your denominator or your numerator. You're going to keep those the same each time. So once you find out the probability, it makes it a little easier to do. You just do the same one each time. Now I do my reduction. So 2 goes into 8 4 times. 3 goes into 9 3 times. Multiply across, and I get 1 out of 1/20. So, if I did this experiment 120 times, I would only expect to get 3 blacks 1 of those times. Crazy, right? Okay, this is our classical probability. And notice on here, you know, about how many times should I get this? Well, it's what do I expect? If I do the trial 24 times, I would expect 7 blacks. If I did the trial 40 times, I would expect, 7 times I would get 0 blacks. 0 blacks. If I did it 40 times, 21 times I would expect to get 1 black. If I did it 40 times, I would expect to get 2 blacks 7 times. And if I do it 120 times, I would expect to get 3 blacks just 1 time. Okay, so this is like your number 9, the classical probability distribution. Notice I haven't actually used this stuff yet. I told you about getting it, but I didn't use that yet. All I did was say our same stuff we've been doing. If I'm choosing 3 of them without replacement, what's the probability that I get them? And so I can get 0, 1, 2, and 3. And then we just did it. Okay, now I'm going to back up and do the first 8 things, okay? Now I'm going to back it up. So I'm now going to go back to number 1. And again, number 1 is to find a container. You've done that. Number 2 is to make items that make 2 groups. I've got my M&Ms. Number 3 is decide what's white and what's black. We did that. I've got mine. They're just the colors of the M&Ms, and the whites are the colored ones, and the blacks are black. So I've got it. Find a way to select it randomly. So whether that's putting your hand in like this or pouring it out or whatever, make sure that you can select it randomly. Then we actually get to start the experiment. And what we're going to do now is actually do the experiment and see, are our results similar to this? We're going to find out empirically what happens. This is what we expect to happen. This is our, in theory, what should happen. But instead, we're going to now do it empirically. What actually happens when I do this experiment? And so we're going to make first we're just going to make a frequency distribution. And remember, we've done frequency distributions before, where again, we have the number of blacks. It's going to be my random variable. And we said that we can get 0, 1, 2, or 3 of those blacks. And then what we're going to do is we're going to notice the frequency or the number of times this happens. So let me show you what I mean. So I'm going to go ahead and do it. I'm going to pull out 3 without replacement. I'm going to do it without replacement. 1, 2, 3. Okay, so what I got was a black, a blue, and a red, so these are white. So I got 1 black and 2 whites. 1 black. That's what I care about, is the fact that I got 1 black. So I got 1 black. I'm going to put a little tally mark here to let me know I got 1 black. For right now, I've just gotten it once. Okay, I'm going to do that experiment 10 times. I'm going to do 10 trials of the experiment. So there was 1. Now, I'm going to do it again. I'm going to pull out 3 things. 1, 2, 3 things. And again, I got 1 black. So I'm going to record that I got another one there. I'm just making a tally mark now, and then I'm going to make the frequency distribution here in a minute. Okay, I'm going to put them back in. That was 2 trials. Now I'm going to do it a 3rd time. So this is 3 trials. This is the 3rd trial. 1, 2, 3. And again, I got 1 black. I got 1 black. So I'm going to record that I got 1 black. So empirically, so far, it looks like I can only get 1 black. If somebody were to come along, they'd be like, you can't even get 3 blacks. That's not possible. Or it's not possible to get 0 blacks because we're just looking at what I've seen here in my trial. That's it. So, you know, well, I've done it 3 times. I'm going to do it 7 more times. 1, 2, 3. Oh, look, this time I got 0 black. All white. So this time I got 0 black. All right, I've now done it 4 times. I need to do a total of 10 trials. That's right, it's 3 out of 10 so far is that probability. Or actually it was 3 out of 3, it was a full 100%. Now it's 3 out of 4. But now I'm going to do, but I am going to do it 10 times. Again, no black. So I'm just going to put a tally mark. That's 5 trials. By the way, I love the cards idea. There you go, Adam, use those cards. You can do 2 sets. You know, pick your favorite suit to be black. Like maybe your favorite suit is hearts. Make those black and everything else is white. Three of them, and I got 1 black again. So I've done 6 trials. This is trial number 7. Hey, I got 2 blacks finally. 2 blacks. That's 6, 7 trials. And there's 1 black. That's 8 trials. No, Zoe, I'm taking all 3 of them and putting them back in. I'm just counting the number of blacks each time. So all of them go back in every time. So it's without replacement because I didn't take it out and put it in, take it out and put it in. This was 1 trial. I took all 3 of them out. So this guy came out without replacement. Let me do it a little slower to make sure you understand what I'm doing. Okay, let me show you. I wrote that one down. So let me do the trial again. So here's another trial. I'm going to take it. I'm taking out 1. I'm not putting him back in. So this is what I mean by not replacement. In the with replacement one, you'll put it back in before you pull another one out. Then I'm going to take another one out and not replace it. And then I take the 3rd one out. I was doing that really fast, you're right. And now I look at them, I go, oh, there's only 1 black. So now I've done it 2, 5, 6, 7 times. I still need to do it 3 more times. And what do we expect to get? Well, looking at this right now, I'm expecting to get 1 black. I mean, it looks like that's more probable. And if we come back over here, it looks like it's more probable here as well for me to get 1 black. So it makes sense that I'm getting 1 more often. Okay, so I'm going to do it again. I'm going to pull out 3 of them without replacement. 1, 2, 3. This time I got 2 black. So I'm recording that 2 black. What I expected. I expected to get 1, but I got 2. So now I've done 6, 7, 8, 9, 10. Oh, I've done all 10 of my trials now. 6, 7, 8, 9, 10. Yeah, I've done all 10 of my trials. Okay, so this is the data that you're going to turn in. One of the things you're going to turn in is the data collection. Here, I just collected my data. That's the record of your data collection. Now, I'm going to turn this into a frequency distribution. All I do is then write the numbers. I got 0 2 times. I got 0 blacks 2 times. I got 1 black 6 times. I got 2 blacks 2 times. And I got 3 blacks 0 times. This is the frequency distribution. So there's your number 7. Number 7 on the task says make a frequency distribution. I just did it. There it is. Now, I'm going to make this into an empirical probability distribution. So now I'm going to do empirical probability. So if we had done that 24 times, we would expect our number over there to be 7. If we had done it 40 times, we would expect it to be 21. It doesn't mean that it always happens, but that's how we compare this classical probability with the frequency distribution, or with our empirical. Okay, but we only did it 10 times. So here I'm going to take each one of these to make it into an empirical probability. Instead of doing frequency now, I'm going to make it into the probability. And this is empirically, well, I did it 10 times. So it's 2 out of the 10 times. So you remember when we did relative frequency back at the beginning of the semester? Well, this is that similar idea. It's out of the 10 trials. So probability is that same way, where it's just out of the total. So 6. Okay, so now I had 6 out of 10, and this is 2 out of 10, and this is 0 out of 10, which is still 0. I really should simplify those to make it 1/5, 3/5, and 1/5. So we can kind of compare our empirical probability to our classical probability. You know, this is 20%. 20% is 2/10. If I come back over here and I say about what is that percent, well, you know, this is really close to 25. And if I wanted to get up to 100, 24 times, you know, pretend it's 25, we would multiply the top and the bottom by 4 to get up to 100. So it's about equal to 28%. So we expected to get 0 blacks 28% of the time, and we got it 20% of the time. So empirically, we were a little different from the classical, but, you know, not too far off. Here, this one is 60%. So again, to get up there, I need like 2 takes me to, I need 2.5 of these to get to 100. So if I multiply the bottom by 2.5 and the top by 2.5, so, well, 2 21s is 42, and a half of that is another 21, another 10, so about 52%. While you're doing it, you could just take 21 and divide it by 40 and see what that percent is. I say it's close to 52%, in which case this 52%, that's pretty close to the 60%. And then multiply this one again by 2.5, because that gets me to 100. And so 2 of those is 14, and another 3 is about 17. Oops, 2.5. So it's about 17% of the time. And this is 20% of the time. So that's pretty close. That's pretty close. And then look how little this percent was. It was a teeny tiny percent that we should get it. We shouldn't get that very often. And sure enough, we didn't get a single one of them. So while it doesn't match it exactly in theory, we did empirically get pretty close to it. And if we did this experiment enough times, if we did it over and over again 1,000 times, our percentages of how many times we got whatever number of blacks, we would get closer and closer to that classical probability. So that's kind of the idea, is that as we get bigger and bigger, it gets closer and closer to that probability. Okay, but your job is just to turn in. Your job is to do this experiment and then turn in your empirical probability distribution, your data of you recording it, your classical probability distribution, your picture of yourself or your video of yourself doing the tasks, and of course post it on social media and tag Simpson_math, and you get a bonus point for that. And that's about it. Math made simple at Simpson Math.